Alright, hello everyone. Today I'm going to go over a quick overview of how to install ROS and get it up and running. I have a virtual machine set up here. This is a completely fresh version of Ubuntu 20.04. So I'll be going over how to install ROS on that. I will also make the virtual machine available online so you can take a look at it yourself and just use it as a starting place if you want. So anyway, with that, let's get going. So I'm going to open up the file, or a web browser, and we'll go search just ROS install. We'll click the ROS installation. For Ubuntu 20.04, we're on ROS Noetic, so we'll click that. We are Ubuntu, and with that we can get going. So I'm going to open a new terminal by pressing Control-Command-T, and there we go. And here we go. So first we're going to add our sources to apt, just like that. Set up the keys. Whoops. The password on this virtual machine is ROS, user ROS, password ROS, so enter that. There we go. We'll set up the keys, paste that in, hit enter. There we go. We're going to do a sudo apt update. Let that go. This should take a minute or two. Pretty quick. Great. Okay, so here you have a choice. You can install the full desktop, the basic desktop, or the ROS base. This is something that I recommend installing on vehicles, robots, and things. But for the desktop install, it's nice to have all the tools ready to go. So we'll just do the full install. And I'll go ahead and start that. So we'll say yes. This is 3 gigabytes to download, so it's going to take a little while. Alright, so it looks like the download just finished, so let's keep going. It looks like we're done with the installation. Now we're going to set up our environment. So you have two options here. In general, you can manually source your ROS environment by typing this into every terminal, or you can add this line to your Bashrc file, so anytime you open a new terminal, that will automatically be sourced. That's how we're going to set it up here. I think that just generally makes it a little easier, so I'll go ahead and paste that in there. And this will tell us to just reload the Bashrc file, so we don't have to reopen our terminal. So right now, if I type ROS cd, it should take us into the default ROS install space. Okay, there's a few more dependencies that we need, and we'll just get those guys. This is a quick one. There we go. Initialize Ros dep. This will just help us get dependencies for ROS packages later. Okay, that's all good. So we'll initialize and then update, and we're pretty much good to go. Okay, now that we've done that, let's set up a Ross Workspace. So we actually have a nice little place to work on our own projects. So we'll cd back to our home directory. We'll make a directory. We'll call it catkin workspace, sort of the default. Change directory into catkin workspace. As you can see, there's nothing in there. Make dir source. Okay. So if we ls, so this is basically the minimum viable setup for a catkin workspace. So you can see we've created here in our home directory. Let me open that up, and you can see it's the catkin's workspace just has an empty source directory. This is all we need, and we can, from within the catkin workspace directory, we can call catkin make, and that will go ahead and make the project and initialize the workspace. So you see it's created a couple more folders here. All right. So there's one more thing we want to do. We want to be able to source our local workspace. We want to be able to source our local workspace instead of the default ROS install one. So what we actually want to do is go up a directory and we'll gedit the .bashrc file. Whoops. There we go. And if you look, let's make this a little bigger. All right, so there's that line that we added before from the terminal. We'll just go ahead and we'll copy that one, except now we want to source the setup file that we just created, or in our own workspace. So we'll do source from our home directory. We'll do catkin workspace /devel setup.bash. So if we look, so here's our home catkin workspace devel. You can see that there is a setup.bash in here. This is the actual file that we're going to be sourcing. So I'll go ahead and save that, close that, and we'll source our bashrc again. And now if I type ros cd, it takes us to our catkin workspace. And if I open another terminal, ros cd, it will automatically be the default setup. So we're pretty much in good shape. So let's go ahead and get a basic package in here. I have a template package that I've created. This is a good place to start work on your own projects, or it's a good thing just to test your build system. So I'll put this link in here in the video description, but we can go ahead and clone that. So let's cd to our source. Whoops. There we go. And you see there's basically nothing in there. And I will paste our git. There we go. ls. Now you can see that the template package is in there. We'll follow along here just so you can see. Template package, and it has a couple messages in, or a couple folders in there. The source, which has the CPP files. We'll go over this in a little bit later. Nodes, which has other files, and yeah, basically that. So now, if I go back up a directory, we can type cat make, and we should now you see we actually have something to compile, so it takes a little bit longer. And we can try, just to test that this all worked, let's do ros run template package, and if I hit tab a couple times, it'll give me the option of all the things we can do. We'll just type the hello node. That's just a little hello world. And now this isn't going to work because this requires a master to be running, so we'll go ahead and close that and open a new terminal. Just type ros core. Okay, so now this node will actually be able to connect to the master and it will run, and all it does is print hello world. Okay, great. So we basically have our ROS environment set up, our build system set up. The next thing I'm going to show you is how to get my personal favorite IDE for doing ROS things set up, and that's Qt Creator. So we're going to Google Qt Creator-ROS. You have to make sure and get the ROS version because, yeah, the default version, although it will work, this is much better configured for doing ROS-y type things. So we're going to click the online installer. That seems to work fine. They don't have a version for Focal yet. They only have Ubuntu 18.04, but this one actually seems to work fine. So we're going to go ahead and save this file. All right, so we'll click Open. There it is. So this is a run file. You can either chmod plus X this in the terminal, or another way to do it, if you want to do the more GUI way, is to just right-click it, click Properties, Permission, Allow Execution as a program, and now we can just double-click it. Okay. So we're just going to go through the steps here. That's a fine location. We want to actually make sure we click Install and click Next, accept the license, install. This will just take a minute. All right, so that's finished. Now we can press, well, let's close some of these windows. Close all these tabs. We'll go ahead and leave that terminal for now. But now we can either click the dash button, or we can press the system key or the Windows key. And now we can just search Qt Creator. We do not want to take the UI tour. I'll actually go ahead and add this to the favorites, so this will stay up here if you guys go ahead and download the if you download this VM. It'll just be a shortcut right there. Okay, so projects. We want to create a new project, other, right? Ross Workspace. Choose. Let's call this Catkin Workspace. We're in Ros Noetic. This is an important step. I have not yet got Catkin tools to work, so I just prefer Catkin Make as the build system. And then we got to select our location, so we'll click Home, Catkin Workspace, and we're good. So Home, Ross, Catkin Workspace, great. Next, Finish, and we're good. So if we open this up, you can see there's our template package. We have all the files we created in there. Template package node. All right, they're all there. So this is the program that we ran. Let's zoom that in a little bit. Make it a little easier to see. So yeah, this is just a basic hello world. This is more of an object-oriented base. I have a I'll explain how to use this template package here in a minute, but let's before we get into that, let me show you how to build and run things in the IDE here. So all we have to do, if we want to compile, we don't have to type catkin make anymore in the terminal. We can just type, or we can just click the build icon, and you can see that the progress bar goes over there. Everything built fine. And actually now, all the little warnings went away, and we can actually get code suggestions and tab complete and stuff, which is going to be really nice. Okay. So that's all good. If we actually want to run one of these nodes in here, we're going to have to go to Project, Run. We will add a custom executable. Let's rename it to Hello Node. We're going to browse for the Hello Node, and those live in build devel lib, the name of your package, and Hello Node. Okay, so we can go back to our edit page, and if I click run, it's probably not going to work again because we don't have a ROS core going. Yep, sure enough. So let's type ROS core. We'll get one running there. We can just leave that running in the background. And yeah, as soon as it connected, it was able to print hello world. We can go ahead and try that again. Okay, that's all well and good. Okay, so another thing we can do, let's actually expand this a little bit so it does some ROS-y things. Let's make it a publisher. So we'll do ROS C++ publisher. I'm just going to go ahead and steal the tutorial code here. So just steal the tutorial code. We'll clean out the comments so you guys can look at those on the website, and I do recommend doing that if you're unfamiliar with this. But let's clean them out so we can see more in the video. There we go. There we go. There we go. All right, so let's just make sure there's no disasters and that we can still build. Okay, that looks good. So let's talk quickly about what this does. I'll hit escape a couple times to close all the unnecessary tabs. So this is going to initialize the Ros node, and it's going to initialize it with the name talker. So this is it basically allows the Ros core to know who's sending messages. We're going to create a node handle n. The node handle is basically your connection to the Ros master. It allows you to say, I'm advertising a topic. It allows you to look up topics that you want to subscribe to. And it allows you to get parameters and do all things like that. But for now, we're just going to go ahead and advertise a topic. We're going to say we're sending a string. That's what the inside of the angle brackets mean. But this could easily be a sensor message IMU or a geometry messages pose, something like that. We're going to call the topic chatter, and we're going to buffer 1,000 messages. So for some reason, we send a message and it can't be published right away. It'll go into a queue, and then they will queue up until there's 1,000 of them. If you can't send enough, it'll queue up 1,000 messages and send them next time it gets the chance, up to 1,000 messages. We're going to create a loop rate for 10 Hertz. And basically we're going to go into a little while loop here. So the while loop says while Ros is okay, so basically while Ros is running and everything's happy, we're going to create a string message. We're going to pack in the message with hello world plus the count, the number of loops that we've sent, just so the string changes over time, makes it easier to see. We're going to, then pack that into the data part of the message. We're going to go ahead and print the message just so we can see in the terminal that things are running. Then we're going to go ahead and publish the message. We're going to call Ros spin once. That basically tells Ros to handle all the publishers, all the subscribers, and all that sort of thing. This is actually more important in a subscriber, or something that has subscribers, but for now we'll leave it in anyway just because it's good practice. We will sleep for the loop rate, so we'll sleep for 1/10 seconds. And we'll increment the counter. All right, so that's all pretty straightforward. So let me go ahead and click Run. Great. So if we look in application output, hopefully, yeah, it is showing what it's printing there. Let me zoom that in so you can see it a little better. Okay. But there's a couple other things we can actually do now that we have a working Ros node. I'll open up a terminal. One of the tools that you're really going to want to get used to is Ros run Rqt topic. And I actually think there's a problem with this that will prevent it from running. And we'll look at that in a second. But anyway, before we get into that, let me explain what this command actually means. So Ros run says, look up a Ros program. This first argument specifies the package. The second argument specifies the actual name of the executable. But I think this is going to fail because Python is not configured correctly out of the box. So the easiest way that I've found to fix this is sudo apt install Python is Python 3. This is a holdover since the code hasn't been properly, I don't think the code has been properly updated from the original version. And remember, the password here is Ross. Great, there it goes. And we'll try to run that again. There we go. Now we get our terminal. So anyway, if I want to look at some of these topics, I can just click Chatter, tab it down, and you can see we're getting Hello World at 10 Hertz, and it's properly incrementing, and things all look great. So good. This is a good way to examine what exactly is going on, what messages are being sent in your ROS system. I'll go ahead and close that. This is another good opportunity to talk about the Qt Debugger. This is another super handy tool. So if I click on the side of a line number, it'll actually put in a breakpoint. And then as soon as the execution of the program gets to that breakpoint, it will pause the program and it'll allow us to look at the variables that are available. So, like for example, count. That's one of the only things that actually changes iteration to iteration, so that's 1430. We can actually look at our message. You can see that it says Hello World 1430. That's how we would expect. And this is just the node handle, so there's not going to be a whole lot we can examine in there. But yeah, this is going to be a useful debugger, a useful tool. I can say continue until we hit the breakpoint again. So I'll do that. And you can see now we're on 1431. And yep, we can basically artificially pause the program and see what's going on. So this is a useful little tool, and one of the advantages of using Qt Creator to do this sort of thing. Okay, let's go ahead and continue that running. So all I did was remove the breakpoint and hit continue. And I'm going to go ahead and just stop it. Okay, let's talk about how this build system sort of works. This is all very automatic. As long as you aren't adding any fancy libraries or anything, if you're doing basic ROS stuff, you should never really have to mess with the CMake lists. You should get in contact with me if you want to add more complicated libraries or anything. We can easily add those. But for this tutorial, let's just talk about the basic package. So this is the standard sort of layout for a ROS package, is you have an include directory, and that has another folder named after the package name. So in this case, template package. And in there, you'll put all your header files. So if you're making a more object-oriented based C++ program, you would put the header in here, and you put the source files, the corresponding source files with the same name, only CPP, in the source directory. Yeah. So, and then we can just link that. We can include the header there and get going. But for this case, we're going to mostly be sticking in the nodes. Any CPP file that you add to the nodes will be converted by this CMake configuration into an executable. So if I want to add another executable, I'm just going to say add another C++ source file. We want it to be a node. So we'll put it in there, open, and we'll call this a hello sub, not CPP. Okay. And you can see that created the hello sub. Let's go through here and we'll just hijack the subscriber code from the tutorial. Delete the comments so we can see it easily in the video. Okay. All right. There's one little quirk. If you do add a new file, you will have to come up here and click rebuild. That will cause it to look for new files. If you just click build, this won't get added. So just something to look out for. So we'll rebuild, and you can see that looks like it built. Everyone okay. And let's go over here and we'll add we can add another custom executable. So let's go to, that lives in devel, lib, template package, hello sub, command line arguments, okay. I think that's all set. Oh, let's rename it too. That'll make it easier to pick. So this is the run configuration we've currently set. You can select your run configurations here if you want to switch between other ones, but let's leave it on hello sub for now. Okay, in another terminal, let's go ahead and do Ross run template package. And remember, tab twice and you can see the options. We'll run hello node over here, and there it goes. All right, and over here we can press just debug. And we'll see in the application output if this is all working properly. We should start seeing, yep. So what this program does is it just sets up a basic ROS subscriber. It says subscribe to the chatter topic, which is what we're publishing in the publisher node. And when you do that, call the chatter callback. So this is just a function. So this is the function that gets called every time one of these messages is coming in. In this case, it just prints the message, but you could do any number of things. You could even have another publisher inside this chatter callback. You could, augment the string that you received with something else, or you could send another type of message or whatever. But for now, this is basically good enough. We can even hit the debugger here, and you can see at any time we can look at the message that we got, and if we hit next, yep, you can see that it increments the number. So click run, and yeah, it looks like everything is basically going. All right, so while that's running, I just want to go through another couple tools here. Let's open a new tab. We'll do Ross run Rqt. Rqt topic is another good one, but we've already done that. But we want to look at Rqt Graph. This is a useful tool for debugging to make sure that the subscribers and the publishers are working out. So basically, this just gives you a flow chart of who's sending messages, what the message is, and who's listening to messages. So we have our talker node and our listener node. You can see in the middle we have this chatter topic. So it's saying that talker is broadcasting chatter and listener is subscribing to chatter. And you can just see that that's how that's working. For this example, it's pretty simple, but trust me, as things get complicated, you're going to find this to be a very, very useful tool. So we can go ahead and close that. And anyhow, okay, so I think that's probably about enough for this video. I can do some more later if there's any interest in doing a more complicated object-oriented design sort of things. We can get into some launch scripts and do some stuff like that, configuring more complicated projects. But I think this is a pretty good start. Like I said, I'll make this this VM available so you guys can use it as a starting location if you want to, or if you don't have a Linux machine, you can even install it on it. You can even open this with VirtualBox on a Windows or a Mac machine. So with that, I hope this was helpful. Let me know in the Discord if you have any questions.